Hi, this is Nimla Ratnam. In this video, we are going to solve the sums from exercise 8.4 from Algebraic Expressions and Identities from NCERT textbook class 8. So, in this exercise, what we are going to be looking at is the multiplication or finding the product of a polynomial with another polynomial. Earlier exercises, we looked at multiplying two monomials and multiplying a monomial with a polynomial. Here you have two polynomials. So what do we do when we have two polynomials? Each polynomial will have a certain number of terms, right? So what we will be doing is, we will consider each term here and multiply it with each term in the second polynomial, okay? So basically you'll make each term in your first polynomial interact with each term in your second polynomial. That will give you a bunch of terms. Now this, you're going to further simplify it. How do you simplify it? We are going to identify the like terms and simplify it. For example, here 9ab and 8ba are like terms. So you are going to simplify it and write it as 17ab, right? So that is all there is to multiplying any two given polynomials. So here you can see x into 2x is 2x square, x into 3 is plus 3x, this is minus 8x and this is minus 12. Once you get this, what you're going to do is simplify the like terms, which is in this case 3x and minus 8x, which gives you minus 5, right? So that is how we will be solving the sums. So here, let us look at the exercise. So all the solved examples that they have given are, different. Either it's a binomial and a binomial or a binomial and a trinomial. For example, this is a binomial with a trinomial. You just, step by step, you need to multiply each term in your first polynomial with each term in your second polynomial and further simplify it by identifying the like terms. You will get your answer. So let's look at the exercise 8.4. The first question, they are multiplying a binomial with another binomial. So here I have first question, 2x plus 5 into 4x minus 3. So like I said, first consider the first term here, 2 into 4, 8, x into x square. Now I have a minus sign, so minus 6x, right? So the first term has, we have found the combination with all the terms in your second term, expression. Now let's look at the second term, 5, right? Plus 20x minus 15. Okay, we are going to solve it one step further by identifying the like terms. What are the like terms? These two are like terms. Okay, there are no other like terms. So this is nothing but 14x minus 15. So that is your answer, right? So the second question is y minus 8 into 3y minus 4. Again, look at it this way. Y into 3y is 3y square minus 4y. Okay. And then I have minus 24y plus 32. Right. Are there any like terms? Yes, I have like terms here, which is minus 28y plus 32. So that is your second sum. Next I have 2.5L minus 0.5M into 2.5L plus 0.5M. Since you didn't do the identities, we cannot directly solve it. Otherwise, it's actually a minus b into a plus b, which is a square minus b square. Okay, we don't have identities in your textbook. So 2.5 into 2.5 is 6.25, right? L into L is L square. And then I have 2.5 L into 0.5M, which is nothing but 1.25 LM. Here is also again I'm going to get, but with a minus. And finally, I have minus 0.25 M square, right? So further simplifying it, you can see that these two are the like terms. So simplify that and I get 6.25 L square minus 0.25 M square. So that is your answer. Next, a plus 3b into x plus 5. So again, if you take all the terms from the, multiply each term of your second polynomial with the first term here, I have ax plus 5a, and then the second term 3bx plus 15b. As you can see, there are no like terms, so I need to leave it here. There is no further simplification. 2pq plus 3q square into 3pq minus 2q square. Now, this is nothing but 6p square q square, right? And then minus 4pq cube, right? And now the second term. Come to the second term. 3 into 3 is 9. I have 1p and 3 q's. And then I have minus q power 4. 3 into minus 2 is 6. So minus 6 q power 4. Are there any like terms? You can clearly see that these two are like terms. So I have 6p square q square plus 5pq cube minus 6q power 4. So that is your answer. Next question. Sixth question. 3 by 4a square plus 3b square into 4 is outside the bracket. I'm going to take it inside the bracket. 4a square. That means I have to multiply each term inside the bracket with 4. So that makes it 4a square minus 8 by 3b square. Okay. The 4 that is in the given question is outside the bracket. I'm taking it inside the bracket. So that means that each term over here, in this case 2 terms, has to be multiplied with this 4. Right? So once we do that, we have 2 binomials. Okay. Now, let's look at the first term here. 3 by 4 into 4, 4 will get cancelled. So I have 3a power 4. A square into a square is a power 4. And I have a minus sign here. Now 4 2's is 8 and 3 will get cancelled. So I have a 2 as coefficient, right? A square, b square. Now this second term will give me 12a square, b square minus, again 3 is getting cancelled, 8a power, b power 4. So you can see that these two are like terms. So that will give me minus 8 b power 4. So this is your final answer. So that is the first question. Let's come to the second question. Again, they have given a bunch of sums where you have two binomials and you have to find the product of these two. Let's look at the first one. 5 minus 2x into 3 plus x, right? So this will give me 3 5 is 15 plus 5x, and then I have minus 6x. You have to be careful whenever you have a minus sign. Okay, minus 2x square. Are there any like terms? Yes. So now I'm going to write it in standard form, that is the x square term I will write first. Minus 2x square minus x. 5 minus 6 is minus 1 and then plus 15. Right? So this is your first sum. Second sum, I have x plus 7y into 7x minus y, right? So again multiply, you will get 7x square minus xy. Now the second term plus 49xy minus 7y square. As you can see, I have a like term here. I have two like terms which will give me 48, 49 minus 1, and this is your answer, right? So that is your second sum. Third question is a square plus b into a plus b square. Okay, again multiply, you will get a square into a is a cube, a square b square, and then I have this ab, ba is nothing but ab, so I'll write it as ab plus b power 4. As you can see, there are no like terms, so this is b cube, sorry. b into b square is b cube. So as you can see, there are no like terms, so I'm going to leave it as it is. So this is your final answer. Next, fourth question, p square minus q square, 2p plus q. So here again, if I multiply, 2p into p square is 2p cube, okay, plus p square q, right? And then I have minus q square, which will give me minus 2p q square minus q cube, okay. So as you can see, there are again no like terms. So this is going to be the final answer, right? So this is about the second sum. Next, in the third sum, again we have a few sums where you have to find the product of two either binomials or polynomials. So let's look at the first question here. I have x square minus 5 into x plus 5, right, plus 25. So here there are two binomials. X square into x is x cube plus 5x square minus 5x minus 25, and then this 25 over here. You can clearly see that this gets cancelled. So your answer is x cube plus 5x square minus 5x, right? That is the first sum. Next I have a square plus 5 into b cube plus 3 plus 5. Again I have two binomials. A square into b cube is a square b cube plus 3a square plus 5b cube plus 15 plus 5. So only this is the only part that can be simplified. So I have a square b cube plus 3a square plus 5b cube plus 20. So that is your answer. Next, third question. I have t plus s square into t square minus s. Now here again I am going to multiply these two binomials. T into t square is t cube minus st plus s square t square minus s cube. I can't simplify it further because there are no like terms. Next I have a plus b into c minus d, right? What is that? A plus c into a plus b, sorry, into c minus d, right? First let's find this out. This is nothing but AC minus AD plus BC minus BD, correct? Next I have A minus B into C plus D, right? Again two binomials. This is AC plus AD minus BC minus BD. And then I have 2 into AC plus BD, which is nothing but 2AC plus 2BD. Now what they have done is they have added these three algebraic expressions. Either you identify all the like terms and simplify it, or you can use the first method that we learned, which is writing one expression below the other to simplify it. Let me try to do it in that manner. So the first one is here AC minus AD plus BC minus BD. The second one is AC, I'll write below this, plus AD minus BC minus BD, right? And this one is 2AC, and then I have a BD term here, 2BD, right? So I have written the three algebraic expressions by aligning the like terms, and then I have to add these three, okay? So I have a 4AC here. These two are going to get cancelled, so I'll get a 0. Again these two will get cancelled, and here also minus 2 plus 2 will become. So I have final answer as 4AC. Now this can be arrived at without actually writing these one below the other, simply by identifying the like terms and then simplifying them. You'll get the same answer, right? So that is the fourth question. Next, fifth question. I have x plus y into 2x plus y. Okay, and then they're adding another. Let's first find this out. X into 2x is 2x square plus xy plus 2xy plus y square. So when I simplify it, I get 2x square plus 3xy plus y square. Right? This is my first term. Next I have x plus 2y into x minus y. Again, if you simplify this, you have x square minus xy plus 2xy minus 2y square. So you can see that these two are like terms. So there's nothing but x square plus xy minus 2y square. Now these two have to be added. So like I said, again write one below the other. They are actually quite literally one below the other over here. Or you identify the like terms and add them. So I'm going to do it one below the other. Plus y square. And you can see that the like terms are already, in the given arrangement, they are one below the other. So this gives me 3x square plus 4xy minus y square. So this is your answer, right? Next I have fifth question. Fifth is over, sorry, sixth question. X plus y. Now I have a binomial and a trinomial, okay? So here what we are going to do, each term in the first with each term in the second. So this will give me x into x square is x cube minus x square y plus xy square, and then x square, I'll write it as x square y, it's the same thing, minus xy square plus y cube. So you can see that there are a few like terms, like for example x square y, I have minus here and plus here, I can cancel it. Similarly xy square. So the answer is x cube plus y cube, right? Next question, 1.5x minus 4y into 1.5x plus 4y plus 3. And then you have some other terms. First I need to simplify this, right? So this is nothing but 2.25, 15 square is 225, x square plus 6.0 is 6xy, and then I have 4.5x minus 6xy minus 16y square minus 12y. So if you look at the like terms, I have these two like terms, so I'll cancel it, right? And rest everything is, you have to write it as it is, plus 4.5x minus 16y square minus 12y. Now from this, I am asked to add, to this I have to add minus 4.5x and 12y, right? So let me do it in the next step. Either you identify the like terms or write one below the other. Let's do it horizontally this time. X square minus 16y square plus 4.5x minus 12y minus 4.5x plus 12y. So now here you can see these two are like terms. Okay, they cancel out. These two are like terms and they happen to cancel out. So what do I have left? 2.25x square minus 16y square. So that is your final answer, right? So the last question of this exercise and this chapter, a plus b plus c into a plus b minus c. So again, each term with each term over here. Let's look at the first term, a square plus ab minus ac. Now the second term, plus ab plus b square minus bc. Now the third term, right, c into a AC, C into B, BC, C into minus C, minus C square. So if I write this in standard form, first let's check if there is anything that cancels out. BC and BC is going to cancel out. AC and AC plus and minus will cancel out, right? And then I have one AB here and one. These are also like terms which will become 2AB. So I have A square plus B square minus C square plus 2AB. So this is your final answer. So with this we complete this exercise in chapter algebraic expressions and identities, where we have looked at how to add or subtract or find the product of any two given algebraic expressions. Okay. So you've seen that for addition and subtraction you need to look at the like terms and simplify them. And when it comes to the product or the multiplication, first you need to make sure that all terms of one polynomial are multiplied with the all the terms of the second polynomial, and then you will further simplify it using addition and subtraction of algebraic expressions that we learned, right?